So I'm Frederik De Ceuster. I'm a postdoc at the Institute of Astronomy at KU Leuven. So usually I am modeling stars or the exteriors of stars, but I'm also interested in the bigger picture of software developing and programming, and in particular in how AI will change our beloved profession of scientific programming. So hence my talk here about scientific programming in the age of AI. I'll just give a brief introduction, and then Geert-Jan and Frederik will give a tutorial on how to specifically do some things. Cool. So scientific programming in the age of AI, I think, well, I don't have to convince you that we truly do live in the age of AI. So over the years we're getting used to AI beating us at several typically human tasks that go way beyond just distinguishing cats and dogs. For instance, in 2011 we had IBM's Watson that beat humans at the American game show Jeopardy. 2016 we had Google, well, DeepMind's AlphaGo that beat humans at the game of Go. And then earlier this year we had a creation by OpenAI's DALL-E 2 that beat humans at, well, photography, or at least image generation. But it's not only fun in games, so also in science, AI is really revolutionizing many fields. So here, for instance, you see two Nature covers. The left one, where deep reinforcement learning produced a new matrix multiplication method. So just a fast way to do matrix multiplication, a super basic thing you would think. On the right, you see, well, the work advertised of AlphaFold on protein folding. And there's also, well, many other applications that were, well, inspired by AI, inspired techniques. Cool. But I think the reason why we are talking about AI today here at this event was the watershed moment on November 30, 2022, when OpenAI launched its application ChatGPT. With more than 100 million users in less than 2 months, it was the fastest growing application in history then. And among those many users were, well, many scientists and also students. And these scientists and students have been using ChatGPT then, well, to write their papers, to do their homework. So you had, well, many universities and journals who had to quickly, update their policies in order to cope with this. But, well, apart from just like doing their homework, these scientists and these students also use ChatGPT to write software. And that's why we're here to talk about this today. Now, in order to understand what really the power is of these methods, we should know what the technology is that lies underneath it. And ChatGPT is what we call a large language model, or an LLM. So just a very brief overview how this thing actually works. So it's what we call a deep neural network, and it's trained to perform a very simple task, namely to predict the next word in a text sequence. So for instance, there's some problem with the alignment, but I think the point should be clear. So if you give it the words, "this is not A," it will predict what the next word will be. For instance, with 65% chance it will be pipe, or with 35% chance it will be drill. Why are these LLMs now suddenly popping up? It's not only because today we have this vast amount of computing power available, and it's not only because today there's a vast amount of data available through the internet, but it's also because of an innovation in the actual underlying software and in the underlying architecture that they use. Something that's called the transformer architecture. It was invented by a team at Google in 2017, I think. The key things you need to know about this transformer architecture is, one, that it implements some kind of what I call an attention mechanism. So it's a way to quantify relationships between words in your text sequence. So it gives kind of a context to a word within the text. And secondly, it allows you to train your network in a parallel way. So this allows you to very efficiently leverage all the available computing power and data that we have available today. Now, training in this sense means fitting the, well, trillions or even billions or trillions of free parameters of the model to perform this next word prediction task. And the data set on which it's trained is, well, roughly speaking, you can say it is trained on the internet or large collections of text from the internet. And luckily for us, the internet also contains a lot of open source code. For instance, from GitHub, GitLab, or also Stack Overflow, with Stack Overflow having the advantage that it doesn't only contain the code, it also contains explanations of what the code is doing and what is wrong with other pieces of code. So there's lots of information about software and how to develop it available on the web. And all this information is ingested by the, during the training of the large language models, and then can somehow be presented in the output. There's of course a few issues related to this, but just like scraping all your data from the internet. First of all, you can pick up some undesirable biases from just, scraping the internet. And secondly, there is this issue of intellectual property rights. Many of the source codes available on GitHub and GitLab has a license, but once it's ingested in the large language model, it essentially doesn't care about the license anymore, which is problematic. Now I have to say that, many companies are working towards better ways to cope with this problem and to better adhere to the policies in place. One message I want to give you is that I don't want to discourage you to make your projects open source. Please do so by all means, but just make sure that you provide it with a proper license so that the future policies at least can protect your IP. Good. Then, so ChatGPT is actually a very general kind of large language model, but you can also start training these language models on particular tasks, in particular to do software development. And I list here a few of the examples of which, Geert-Jan and Frederik will show you how to use them in a minute. But before we go to the more practical part of the talk, I just want to take a minute to muse a bit about what the future of AI-assisted software development could look like. So in the short term, or actually already even today, we see that these tools are causing improved developer productivity, right? You have AI, at least in my case, AI is already writing boilerplate code, it can write documentation, it can write tests. On the other hand, it's also democratizing software, right? The barrier to entry into software development has never been lower. You can use AI as an instructor. It can provide feedback on the software that you write. It can help you explain code, etc. I have students who are now writing scripts for automating several tasks just because they can ask ChatGPT to, provide them with a script to do certain things. Problem is, of course, that sometimes they don't really know what the scripts are doing because it's just coming out of ChatGPT. But in principle, you could also ask ChatGPT to explain the code to you, and so in principle they could know what it's all about. Third point here is that, I think these technologies can also help to make us more technology agnostic, especially due to the translation capabilities. For instance, there is a large project going on, it's collaboration between IBM, Intel, and researchers at MIT who are using it to translate a lot of the legacy code you have that's written in COBOL, especially in the financial industry, so using a lot of COBOL, a very old programming language. But it's very hard to find developers, to maintain the software because no one really knows how to program in COBOL anymore. So they're trying to translate many of these code bases into Java assisted by AI. Another thing that I think will be interesting in the future is to see how we can use AI to translate CPU or code that was oriented towards CPU usage to GPU code. Something that also Intel is currently working on. Cool. Then in the long term, of course, we probably will see that these AI-assisted tools will lead to another language abstraction, right? So you can view the large language model as some kind of compiler. There are several papers who try to advocate this point of view, where you would get to the point where you could specify your program. So you do the program specification just in plain English or in any other natural language for that matter. And then the large language model can translate this into executable code that would kind of be the holy grail of programming development. And what you would see then is that the software developer would, migrate more from being a developer to more a development manager. Now that being said, I think that, although many tasks will be taken over by AI, it's still, I want to emphasize that it's still important to know what the technology is that lies underneath the things that you're doing. Just like a good manager should know what the processes are that he's managing, a good software developer should still know, the low-level software, the low-level software languages, and also the hardware that's running under the hood of these things.